Right, greetings all, hope this finds you well as always. It's now time for the latest update from the machine shop, where we're up to and what we're on with. First things, I've been off preparing for the electricians. Craig's been in here and he's finished off Repton's piston packings. As you can see, he's drilled and riveted all of these, as I discussed the other week. These are all now done, so the last job they need to do is they just need the heads of these rivets just dressing back, and then the piston packings can be gapped to insinuate a little bit of MIG welding wire into the joins there, and then you bore them out to finish size for the piston rods. So that's the last little job to do with them, and then they are done and finished, which is an excellent job. Dan Middleton's back in again, and he's busily ploughing out piston rings and valve rings. This pot is going to become valve rings, I guess. He's turned the outside and the inside to size. His next job is to start parting rings off that to required thickness. Then once they've been parted off, he then gaps them. You cut a gap into them so that they can be fitted over the piston head. And so you end up, there's some finished rings that are awaiting gapping. These are for 76079 and Eric, as you can tell. So what those indicate is that it's the right-hand front valve head and right-hand rear valve head, incidentally, if you're wondering about the lettering. So those are done, ready to go. So that's what Dan's on with. He's back with us and busily at it. Brian's been at it too, and he's busily rattling out gauge frame fittings. This is for at the request of the boiler inspector, and he's getting very well on with those, actually. The only minor entertainment we've had today is with these little bungs here, because there's two different sizes. There's one lot there, and there's one lot there, and if you look closely at them, they're actually different sizes. Now, what we expected was them to be a British standard pipe thread, because that's the standard. That's what the drawing says. Unfortunately, on 76079, when somebody has, and I'd love to know if anyone knows when this actually happened, when somebody's replaced one of the gauge frame body castings on the back head, instead of tapping it British standard pipe, they've actually tapped it 5/8 UNF, which came as a bit of a surprise, because 5/8 UNF is 18 TPI, the nearest British standard pipe size is 19 TPI, the thread was a bit mung to start with, so we weren't absolutely sure if it was measured right. But when Brian started poking and exploring and machined it one to a pipe size, it wouldn't fit. And then we were discussing what on earth could be 5/8 by 18 TPI. And I said, well, the only thing I can think of is UNF, but that's hardly ever used. So, yeah, so anyhow, it proved to be UNF. Much to my amazement, we also had a UNF die in the stores. So Brian's busily on with making those tomorrow. Then he's just got the rest of those to thread, and that's another job that's done. Another job that came in while I was away is this injector steam valve, and if you look into it, you'll be able to see at about 3 o'clock there is a whacking great cut in the valve seat. There's also something slightly smaller about 2 o'clock. Now this, I've done these before. The only question with this one is that cut is very deep indeed. So we're going to have to find, to be honest, I want to put it into a lathe and actually see if I can machine that cut out, and then see how much meat is left in the seat after I've taken it. But yeah, that's quite impressive. That, for those who are wondering what a steam cut is, incidentally, what happens here is that for some reason the valve doesn't close properly. There might be a bit of muck trapped underneath it. There might already be damage to the seat. And so what happens is that leaves a small gap between the valve head and the seat. Because these valves are usually holding back steam at boiler pressure, there'll be a small jet of quite high pressure, quite high velocity steam and or water travelling through that. So that slowly, or not so slowly actually, will erode the bronze, which is the softer material in this case. The valve head's actually stainless steel. And so what happens is, it gradually, due to the sheer kinetic energy of that stream of gas or liquid, but also any scale or rust or dirt or grit or whatever it's carrying through it, it acts a bit like a water jet cutter. And so it simply cuts through the bronze. And the only way to cure it is you've got to machine that step out. You've got to remove metal from the rest of the seat so that it's level once more, and then hopefully it should last a wee bit longer. So now that's a little job that came in. That job's sort of on a hiatus because I need an angle plate that's actually new on another jig at the moment. But once that first job's been finished, we can get that thrown into the Mostana and get it done. And so, yeah, another job that's come in are these lovely things, and they are the big ends off the J27. They have worn to the stage where there's too much slack in them, and so they need remachining back to round. They're a split brass, but they've also just got the pockets of white metal rather than being solid white metal in them. So what we have to do here is take some material off the two flat mating faces here, so there and there, between the two halves of the brass. You then close the brass up that way, and then we'll remachine it back to round. We'll probably do them in the Mostana, because I reckon I can hold them without the strap. So I'll put two pieces of angle iron round them in a similar way to how I did the big end bearings for the Q6 a year or two back. So that's the plan anyway. So at some stage they are going to be into one of our machines to be dealt with. A job that's come in and is in the process of going out is this. You may have seen something that looks vaguely reminiscent on these before. It's one of the pinions and its associated shaft that operate the extending stabilising legs on the crane. What the problem was, the leg was wound out, but it wouldn't wind back in. What had happened is this pinion here engages with a rack on the leg, and so as this pinion, the shaft's rotated, pinion rotates with it, and that winds the rack and hence the leg in or out. Now, the pinion should be held onto the end of the shaft of the weld. That weld had broken, so what I've done is machine the old weld out and put a 45-degree chamfer in there to act as a weld prep. And so then tomorrow one of our welder types, probably Tom Lee, yet a guess, because the incredible Dougie Foster isn't here and Jules doesn't work Fridays. So we'll get Tom Lee to stick that back together for us, and then that can be done. What it's sitting on, incidentally, here is this is the plate it mounts into, and this collar here, held the taper pin, is what retains the shaft into this bronze bushing here. You can see there's a hole there. Now, much to my great amazement, I managed to get the old taper pin out first go. That doesn't normally happen with taper pins, and so we've just whipped that one out, stripped it down, new taper pin, and then that can all go back together. This thing, incidentally, was made up a while ago for holding these pinions to machine them, because the problem is, with it being a pinion, you can't easily hold it in a lathe chuck, because the chuck jaws always tend to fall. You end up with sort of two chuck jaws on a tooth and one chuck jaw, or multiple if it's a four jaw, in between the teeth. And so I made this thing up. The pinion just simply sits into it, like so. And then if you look at it, you'll see in the periphery of it there's a small split, so that when that's stuffed into a lathe chuck and it's tightened down, that split closes up. It acts a bit like a collet, really, and it rips the pinion very tightly. So that's what that's about. And then in the lathe at the moment, we've got yet more rod brasses. This one for a bit of variety is out of 825. And then finally, on the floor there, we've got the last two rod brasses for 76079. The top one, they're both big end shells. The top one, they're both remetalled as well. The top one has been board finish size and just requires a radius put in one end of it. The crank pin, where it changes diameter from the intermediate bush to the big end bush, has a step in it, and there's a radius in the bottom of that step, so you don't have a stress riser. And so that bush requires a radius putting into the end of it, which will match the radius on the crank pin. The bush underneath it is another that's been remetalled, that just requires finish machining to size. So that's what they're about. We got everything, as far as I'm aware, everything was pressed back into the rods last week for 76. So that's done. We've now got the next stage is the small motion, and then we can start worrying about other things like 8136 or Eric or quite a few. We've got still quite a bit of work to do this winter. So anyway, that's where that's up to. So anyway, folks, we're keeping busy as always, even if I've been off on the other side of the country again. My lads are working very hard without me. In actual fact, I think they work harder when I'm not here. So anyway, folks, hope you found it educational, informative as always. Now take care, and I'll see you around.